Our next speaker is Paul Borgermans, and his talk is entitled ManGO Platform Updates, ManGO Portal, ManGO Ingest, and ManGO Flow.
Okay, thank you very much, Corey. So yes, for those who know us already for a while, we have been starting using iRods for quite some years now. And our focus is active research data management. Today I will give some updates about the platform. It constitutes of multiple components actually, but I will focus on three of them. ManGO Ingest, an ingester tool, ManGO Flow for workflows that we already announced last year, and a little bit also ManGO Portal. There are quite some more developments been going on in the past year, but those will be also the subject of separate talks by Ingrid and by Mariana, my colleagues. Okay, so when we are confronted with our users who want to use iRods as a storage platform, we notice that in spite of offering quite some tools like Globus, SFTP, and so on, there is still quite a large barrier for getting their data inside iRods. So in last summer, we basically started working on a tool to lower that barrier, to make it easier for researchers to ingest their data, and not only just ingest the data as files and then data objects in iRods, but also provide as much as possible already some facilities to extract and even to some extent manage metadata at the moment that data enters the platform based on iRods. Besides that, we also wanted to lower the barrier and offer facilities for researchers to manage and organize their data, and also, of course, metadata. The top level icon is actually the icon for ManGO Portal, which is standing for the web interface. And actually the results of ingestion and workflows can be followed up through the web portal. But first, let's have a slightly more deeper look into what ManGO Ingest is. Well, it's an ingester tool. Of course, it's a Python script based on the PRC, which can be used by researchers on their laptops in their HPC infrastructure, wherever they can run Python, to offer them facilities to ingest data into the ManGO platform and iRods. The script itself initially and primarily actually offers monitoring capabilities on your local file system. So there is no cron job needed or so. It's really internal monitoring. And it offers all kinds of mechanisms for filtering that you can say, okay, I want these and these and these files uploaded and others not based on patterns, globular patterns, or full-fledged regular expressions. And along that also, there are possibilities to extract metadata from files. That can either be path-based or from the files themselves. So it is really a pure Python script. So the only dependency is Python and, of course, the Python iRods clients and a few other modules that are needed for monitoring and for convenience, also for the command line options and so on. So there is no cron job needed or so. There's no dependency on something more to do, but you could if you want to. And it can actually also be used to sync ad hoc. So you can just run the script in a no watcher mode, and then it will upload the files that you specified through these patterns, these globular or regular expression-based patterns. So it provides their powerful path-based filtering. And along then, as I said before, also some ways of doing automatic meta extraction. That metadata extraction can be done through patterns in your paths. So for example, if you organize your data in folders and the folder name is actually can be considered as metadata, you can specify it also in the command line. It will be uploaded along the data in iRods and set as a view triplets. The script itself has some powerful capabilities, but it also offers extensions or extensibility where you can enable custom filtering and also custom metadata extraction. But all in all, it is meant as a command line tool. Now, I don't do a demo right now here of the script itself, so you'd have to do it with a screenshot. But basically here, you see here ManGO Ingest in its default monitoring mode. It gives you all kinds of information depending on the verbosity that you set as an option. And then you can see it and monitoring yourself to see that it does what it's supposed to do, which is uploading files that match certain conditions. Now, the script itself is pretty well powerful, of course, but it has some specific things. So it has actually 3 threads that start at the moment you start the script. One of them is obviously the monitoring that watches for file changes, and this monitoring is basically also file system dependent. If you're native on Linux, on a Linux file system, it will use all the capabilities of the file system to give you the signals, and the script will listen to it. The monitoring thread will listen to it. There's also a delay queue, because whenever a change in a file is detected, it doesn't mean that the file is actually ready to upload yet. So we implemented here a delay queue, which basically ensures that the file is at rest before it starts the uploads to iRods. And finally, there's also a reporting thread that can be just used as a report, but also potentially, if there are some failures during the uploads, to restart them afterwards. And when the script exits or you interrupt it, then that report is generated. Now, to control ManGO Ingest, there are various options. Because the script employs click, which is a cool Python library from pallets.org. That's also, let's say, the global organization that provides also Flask. Flask is used for the ManGO portal. And by virtue of click, we have actually several options how to control ManGO Ingest. The first and foremost is, of course, command line options, which you can see here on the left. This is actually a screenshot of the output of ManGO Ingest when you call the help function. You see there are many options. But it's not only command line options that you can use. You can use also environment variables or a configuration file. And the nice thing actually with this is also that you can actually use them all at the same time. You could use a configuration file to set some global defaults for many occasions that you want the script to run with. Can also set some environment variables, and then finally the really commanding power can always come from command line options that will override the settings from your configuration file. So all in all, it offers, we hope, quite some power for end users, and especially, as I said in the beginning, to lower the barrier for researchers to get their data inside of iRods, and not only the data also, so if possible, the metadata. Now on the first slide, I showed you also this chain, which is, by the way, a nice drawing made by my colleague Mariana Montes. ManGO Ingest is then used to ingest, but there it doesn't stop, and the needs go further in terms of processing files, processing metadata inside iRods. And therefore, we basically created a workflow solution, which we called ManGO Flow. But now about workflows and automation, we know that iRods already provides rules and PEPs. That's true. But we saw actually ManGO Flow also as something bigger that offers scalability and also additional stuff because we are servicing the entire university. We are servicing a lot of projects, a lot of researchers. So we expect also a large need of those custom workflows that we need to do. And we want to make it easy for us with our relatively small support team to create workflows for many users through the reuse and through composition of building blocks that we already provide. Now, where is ManGO Flow not good at? That's actually as a pre-policy enforcement mechanism. The basic thing is that ManGO Flow will run asynchronous tasks. So if you really want to ensure that something cannot happen or that something else must happen before the data is consolidated, ManGO Flow will not be a good solution. Then you should really rely on iRod's native rules, which they are made for actually. Now, workflows can be launched in different ways. We provide several triggers for that. And currently the most important one is actually watching periodically for changes. Changes in files, data objects actually, but also metadata that are there. Besides this periodic monitoring, direct actions are also possible, and we actually use it also in a recent development that we made for cold storage applications, and where users can themselves actually launch asynchronous tasks in ManGO Flow. Other possibilities that are used less or not yet are to launch workflows from custom scripts, but you can also envision, if you want to have more reactivity, to launch a workflow from a rule that runs inside iRods. Now about monitoring for metadata, we had actually a little bit of a caveat with the implementation in iRods. That is when you use jQuery to search for metadata that has changed, and you attach metadata that as an AVU triplet already exists on some object or catalog, you will not see it because you get actually the original modified date, but the original AVU triplet already exists. Well, it's only that modified date that counts there. But we have solutions for that. Besides all these tools that you show, we also have OpenSearch, which is fed from Apache Kafka, an Apache Kafka topic. And there we have some very specialized fields that make actually very powerful searches possible to detect all kinds of changes. Now, to create workflows with Celery, the framework, you can do it the Celery way, of course. This is in pure Python code. This is what you see here on the left. And for those who know a little bit about Celery, it's the old magical apply async once you have created your signature for a workflow, and then it will be launched and handled by the workers that are configured. By the way, we use Redis as our broker and our result store. Now, as I said before, we need to support a lot of potential workflows. Currently, there are not that much. So an important part was also to develop a declarative way of defining workflows. And here on the right, you see part of such a configuration that is then done in a YAML syntax. And I would like to show you a little bit more the details on what the declarative mechanisms are, so you can get the feeling of what we actually mean there. First of all, there are the conditions. So the conditions of when a workflow can be launched starts actually with the schedule already. So the The condition might be like every 2 minutes, something may happen on the condition that some criteria are fulfilled. And on the left side, you see here a simple single criteria. It's just actually matching a subtree inside IRODS. While on the right side, you see here more a case where you can combine different criteria. For example, watching a subtree, but also only launch a workflow when certain metadata on a certain collection, in this case, is set with a certain value then, of course. The further declarative part is basically composition of workflows, composition of basic building blocks. It can be as simple as a single block. For example, here, suppose we want to extract some metadata out of a data object and then put it as a view triplets, or it can be a linear composition. A linear composition is like a chain. And important here is also to know that typically in such a chain, the result of one part is fed as a argument of the next one. How this is declared in this YAML format. In the single case, it's very simple. You just call the name of the workflow that you have defined and declared in your Python codes. And on the right side, you see here a declaration of a chain where several actions are started sequentially. Another option that we support is to let things flow parallel. Typically, many data objects, for example, that need to be treated. And then for every one of them, basically a chain can be executed in parallel. And when all these chain tasks have been done, you can also feed the results into another chain, which can, for example, create a report and finally also send an email out to somebody to alert from, hey, there has been a bunch of data being processed and please take a look at it. Declaratively, this is called a court. This is a direct use of the term that is also used and posted by the Celery framework. And here we see a very simple case of, on one hand, the header actions. The header actions are the parts of the workflows that will operate on the different data objects. And finally, the aggregate actions, which is also just a single one that just creates a CSV file with some results. With every action of here, you can pass on parameters in the template that can be very case specific. In other cases, some defaults can be used. Yeah. An important part actually, in order to enable composition, is something that goes along with it through pattern matching. You already have, you see it here maybe, that there is some mustache-like syntax with data object inside. This is actually a parameter that can be used by the scripts in themselves. And in this pattern matching, we actually support two ways in ManGO Flow. One of them is full regular expressions, Python regular expression that is. And here you see something that will maybe look like something totally illegible. And for some others, it does make some sense. What we see here is basically named parameters in regular expressions. Named parameters that then are filled with the values that match and that can then be used further in the workflows. A much more simpler syntax is basically a mustache syntax where you can just say, okay, something that sits between two path delimiters. It's just called a subproject, and we do not deal with regular expression syntax here. Then that's actually at the, let's say, inputs or the source part of pattern matching and in these composition workflows. We also have typically destination formation. For example, here is a simple example of a move operation where you basically use the named variables from the source path, and you use them to construct a destination path. Now, what we use here is not just string interpolation from Python, but rather using the Yinya template system, because it's much more powerful. You can put also operators, and here's an operator that basically extracts the metadata from a collection. Another consideration with ManGO Flow is user management. So the famous client user, when you initiate a session, since ManGO Flow operates by itself, it must be instructed to use a certain user. This can be a rots.min account that we call the operator account, can be a pipeline account, or it can be just the owner of the files, of the data objects inside iRots. So all in all, we provide quite some building blocks for the various parts that can be involved for workflows. So on data objects and files, it means copy, move, validate, metadata extraction, validation, normalization, translation of it, and then finally reporting, which can be done in the form of also additional metadata that can be set, or files can be regenerated, or emails can be sent. Now, if these building blocks are not enough, what an skilled researcher could do is create their own tasks and submit them to us. But most of the time, it will be us who will be creating a new task. And in this case, we basically had some requests for extracting metadata out of some special files, and we thought, okay, EXIF tool can do that. And then let's create yet another new building block that has some dependencies on external tools, of course, but then can be reused across other workflow implementations. Okay, so far on ManGO Flow. For the ManGO portal, I'm not going to tell you that much because there are 2 more talks on dedicated projects. But let me say at least that the ManGO portal now even supports more extension points. You can register a Python blueprint with a system that itself then self-registers to appear, for example, as a new tab when you view an object in the ManGO portal. Another example is also more fine-grained template overrides. Here is an example of a gallery view where the normal content tab that shows just boring names here shows thumbnails of the pictures that are stored within it. And how this is done, this is also through configuration in YAML files, where we basically have this template override system that is applied in many places in the ManGO portal, and where you can say, okay, for a normal collection content view, use then another template which gets the same parameters as input, but which will render it differently, and then also a criteria, and that's here. It's a criteria that it is actually only applicable for a certain project inside the ManGO portal. So you see, this allows then for all kinds of display customizations. Now for the future, for ManGO Ingest, we plan to do some more refactoring, especially modularity. This has been a question also from our what we call local ITers. That's typically our skilled people at the various faculties. To be able to use part of ManGO Ingest, for example, the monitoring facilities in their own scripts that are also feeding potentially data into iRots. Besides that, we also are constantly working on stability and robustness improvements based on our experience. So, and with stability robustness, I do mean stability and robustness towards external events like network outages and more calamities. There's a small somewhat in gray. There are also questions for egress functions, but having seen the talk on iBridges, I think we will first look at iBridges to see if we can reuse that because it looks super cool. For ManGO Flow, we plan to make a graphical user interface, basically mostly for us to do workflow definitions, create, read, and update them inside the ManGO portal. Also to have monitoring to know what's going on, and we'll also create quite some more building blocks. For the ManGO portal, we plan on refactoring more and finally also some more plugins for the next year. And that basically concludes my talk, except for mentioning also all the people that are involved in the ManGO platform. There are quite some here on this slide, but it's not all. There are also the local ITers in which we have much more interactions lately in a very systematic way. So all in all, for the ManGO platform, many people are involved at various levels from support to development. Okay, that's it for my talk. Thank you very much. And if you want to check out source codes, we have our GitHub site, which normally contains everything except ManGO Flow, but it will appear soon.
All right. Thanks, Paul. All right, we can take maybe one, maybe two questions. Do we have any questions from the audience?
Okay. Question, I'm Claudio Cacciari from Surf, and a question is about the ingestion flow. Is there any mechanisms to throttle the amount of data during the ingestion? I mean, you could decide to ingest a certain folder or data without knowing in advance how many files are there or how big it is, and could kind of overflow your system, right? Is there a way to limit that?
I didn't quite get the question. The audio is for me very weak from the room, actually. Can you maybe Corey repeat it?
Yes, so is there any
sorry.
mechanism to throttle the amount of data or file that in the ingestion flow? Because sometimes may happen that they overflow the system.
Yes, okay. There can be, well, I should answer there for both ManGO Ingest and ManGO Flow. For ManGO Ingest, it's very simple, it's serial. So there will not be parallel upload of many files into the system. And for ManGO Flow, we currently do not need it, but basically the throttling mechanism that we have is to have not that many workers available. So when you think of this massive parallel use case, basically the tasks will queue up inside the message broker that we use in Redis, and only when a worker is finished and becomes available again, we'll take the next task. But avoiding overwhelming the IROS backend is definitely a concern that we have. And there are also quite some mechanisms in Celery to deal with it, from throttling or even by design on how you basically start these workflows themselves. I hope that answers more or less your question.
Okay, there is language on the ManGO portal get readme saying in the near future the KU Leuven specifics will be entirely decoupled from the generic code base, so a default installation will work with a vanilla iRods installation. Does this reference generic code base mean that iRods will be adopting ManGO portal as a supported interface, or is it just that KU Leuven will still be the main project host and form a generic fork listed as clients on the iRods website?
Well, we are not in the position to say what IROS consortium should support or not, but definitely it is the case that we, and we are sorry a bit late with that, with the refactoring of the ManGO portal and move out to specific KU11 parts, but we still plan to use it to do that quite shortly. To have indeed on one hand, a generic portal solution that can do a lot out of the box. By the way, ManGO Flow is not tied to ManGO Portal or as such. That is can be run totally independent. You don't need ManGO Portal to run ManGO Flow. And yeah, what concerning the adoption of it, we know that there are a few organizations in a few countries are adopting it already now, in the sense that we get some questions for that from the Netherlands, Austria, Italy, and a few more that I cannot disclose at the moment.
Okay. Thanks, Paul.
Thank you.